Hey, welcome back to ZK MasterTech. Today we're still here at Millennial Farmer's place and we're going to dive into the planter a lot more. We're going to go into the row unit and tear it down and show you guys the maintenance and the wear items and the adjustments on the row units, and then we'll get more into the hydraulic downforce and how to bleed that system and get it calibrated. So this video is going to be a lot more in-depth into the planter itself and what things you need to look for and check and how to adjust stuff. So it's going to be a great time. Let's check it out.
Alright, so now we want to actually go through a row unit and we want to talk about some of the key things that we need to be looking for when you're looking at your planter. So we're going to just start by kind of disassembling the row unit and going through some talking points on some wear points here. So first thing we're going to do is remove this vac hose and get him out of the way. Then we're going to remove our CCS hose, undo him, pull him, get him up out of the way. Unlatch our metering unit itself. We pull him out of the way. We'll get to him here in just a little bit, but for now we're going to set him out of the way. We're going to remove our hood. So we can just take the latch straight up, roll him out of there, and then the hood comes off. Next thing we want to remove is our actual brush belt cartridge. So to do that, we put our hand back here in this hole, pull back until you feel it disengage. And then you're going to bring him up and out of there. Now you do want to go ahead and remove your seat tube sensor harness at this point. Pull him up and out of the way. So we'll get to him in a minute as well. But we're going to set him to the side for now. So now we have the motors exposed. A couple things we want to look at in each one of these motors. We want to look at the actual drives. We want to make sure they turn freely, no binding, no kind of grinding, anything like that. And then where the meter and the brush actually engage the meter or the motors, we want to go ahead and look at all these splines and just make sure we don't have any teeth missing, any type of wear, anything like that. So these all look really good. Don't see any signs of wear here. They both turn very freely. Nothing, no grinding, no binding, anything like that. So those look really good. And then I just do a visual inspection down in here. And what I'm looking for here is any obvious signs of wiring being pinched, severed, anything like that. Not a whole lot you can really see down in there, but just looking for obvious signs of pinch points. Wiring harnesses that may be frayed, cut, something to that effect. So once we look at that, everything looks good there. We're going to move on down on the row unit itself. So this is your gauge wheel. So this is what is controlling depth of the actual seed. So we have a couple different parts here. We have the wheel itself, and then we have the gauge wheel arm, and then the gauge wheel bushing. So we need to check a couple things here. We've got a bearing in this wheel. So I usually just give them a spin, make sure they spin freely. And then I lift them up a little bit and I want to see if there's any kind of play in that bearing. As you can see here, this one is really tight. We don't have a lot of play there. So the next thing I want to do is make sure that they do actually move freely. And then we want to make sure that we don't have a ton of wear in our gauge wheel arm itself. So if you pick up on this and rock him back and forth, as you can see on this one here, we've got quite a bit of movement in this gauge wheel arm. Now, the problem with this one actually is that the bolt itself is actually loose. So when we got to it, it was just actually backed off a little bit, so we could tighten that up to take that play away. But for now, I'm going to go ahead and remove that. And we can show you what we're looking at a little better. So we pull that guy out, we can remove our bolt. And this is the actual bushing that we're actually looking at. This is the new style bushing. They really made a lot of improvements on these bushings. We were having high wear rates on these, and they changed the design of these quite a bit to kind of keep some of that wear out. So you can see here, as I'm wiggling that bushing back and forth inside that arm, very little to no play. So once we get that back on there and tightened up, it'll tighten right up. So now that we have that off, it exposes our openers. Want to look at that scraper, make sure we don't have anything broke, you know, that we don't have too much wear on the scraper. We've got a nice edge here. It's going to keep that mud and muck from building up on our disc opener here. So that one there looks to be in pretty good shape. So we're going to go ahead and remove him by removing this 10mm bolt. Now we can remove the scraper. So you can see we've kind of got an edge here. So once we get down to there, this bevel is gone. That's when we need to start thinking about replacing those scrapers. This one looks to be in pretty good shape. I think we can run that one another year. No problems there. We do have a rubber cap that goes over that to protect the bearing. So we'll want to remove that cap. But we also, when you're looking at your row units, you want to make sure that these caps are there, because if we lose the cap, now we can introduce dirt, things like that into that bearing, which we don't want. So we'll get him out of the way. We're going to go ahead and remove the opener itself. When you do this, there's going to be shims behind this guy, so when you pull these off, we want to make sure we don't drop any shims, or if we do drop them, that we get them back on there. So we pull that guy off, and there's your shim pack that you can see, and we'll go over the importance of him in a little bit, but basically that sets your contact on your openers, and we're going to show you guys how to do that. But just make sure we got all those shims off. If you are replacing openers for any reason, a lot of times when you pull one of these off, you'll have a shim stuck to that opener like that. We want to make sure that we don't have any shims left over. We've got all the shims off and then back on our stud there. So while we got the opener off, what we're looking for here is any obvious signs of damage, any big chunks missing out of it, anything like that. And then we want to go ahead and measure the diameter of this opening. So a new opener from Deere is going to be 15 inches in diameter. When you get down to 14.5, that's when you want to start thinking about replacing, because when you get to 14.5, you're going to lose this beveled edge. And that beveled edge is what's doing all the work. So if we lose that beveled edge, we're not creating the true V, and that's what these are called, as true V openers. So as they penetrate the ground, they actually create a V in the ground and gives a nice trench for that seed to sit in. If we lose that opener, or our contact point isn't correct, what we'll actually create is a true W. So as the seed is released, it can roll to one side or the other, and then you're going to lose your seed to soil contact. So we're going to go ahead and measure this one. So I'm just going to flip him over to the flat side here, and just edge to edge. And we're not quite 14 3/4, but so those will run another season. Depending on the acreage you're going to walk across, this is where you're going to want to make that decision. But we've got plenty of wear left over on this guy. He'll definitely make it one more season. But if we're at that 14.5 or lower, that's when we need to start thinking about replacing these openers. But we're good on these. These will run another year. So while we've got that off, the next thing we want to look at is our rock guard. I just want to make sure that bolt is in there, and then make sure that we don't have any abnormal wear, anything broke in there. So this is going to protect the actual brush belt. If a rock does happen to pass through here, we don't want it to hit that brush cartridge. So that's what this guy's here to do, is kind of knock him out of the way and take the beating instead of our brush belt. We'll set that guy aside for now. Another thing that we have in here is the walking gauge wheel stop. On these planters with individual row unit hydraulic downforce, this is our actual sensor that's telling the system what to do. So as this wheel comes up, it's going to put pressure on that sensor right there, and that load cell is going to report back to the system and tell the actuator for the hydraulic downforce what to do. So a couple things you want to look at here is just make sure we don't have a lot of wear on they call this the mustache part. We want to make sure we don't have any wear, any huge divots, anything like that. That one all looks good. And then the most important part, if you want to come around here, there's a snap ring holding that guy on there. And we've seen a lot of times where that snap ring comes off or breaks. Once you lose that snap ring, this mustache is allowed to just fall off. And now you have no depth control anymore. So that row unit is just going to plow as deep as it can possibly go. So we want to make sure that snap ring's in good shape. That one there looks good. So I think we're good on all that. So let's go ahead and put this part back together and we'll show you how to shim out these openers. So what we're talking about is the points where the two openers come in contact with each other, and we're going to achieve that measurement with these shims. So right now we have 1, 2, 3, 4, 5, 6, 7 on this side. So I would guess that we have 7 or 6 on the other side, but we're going to change that to get that contact point. But we don't want to have more than 1 shim difference from side to side. So you wouldn't want to do like 6 and 4. You would want to keep it within 1 shim difference from side to side. So we're going to put that opener back on.
What size are those nuts?
24.
Okay.
I like to give it a good spin, make sure everything's good, lined up. And then we're going to get our special tool out.
Post-its.
Post-it notes, piece of paper, something like that. I like the post-it notes. You can take them, you can kind of fold them in half like that. We're going to come up from the bottom side of the opener, in between the two, and we're going to slide that in there until that paper stops. We're going to take another one. We're going to come in from the top, and we're going to slide that down in there until that piece of paper stops. So now both our papers are in there. We're going to take our tape again, and we're going to measure the distance from the edge of that paper to the edge of this paper, and we're sitting at not quite 2 inches. So what you're looking for there is 1.5 inches to 2.5 inches of clearance. So if we had more than 2.5 inches, we would want to start playing with our shim pack to get that contact point there. 1.5 inches to 2.5 inches is what you're looking for there, edge to edge on the paper. So we're not quite 2, so we're well within that spec. But as the openers wear, you may lose that contact point. So we want to make sure we're checking that. Every time you replace openers, that is going to be an adjustment that you're going to need to make with those shims. So just kind of keep track of how many shims you're using on each side, and then you can repeat that from row to row to row. So now we'll move to the closing wheel system. So this one does have the pneumatic closing wheels on it. So we'll pressurize it a little bit later and make sure we don't have any air leaks. But one of the big thing I'm looking for here, once again, we have a bearing in here. We just want to make sure that we're not grinding, any binding, anything like that. We want to make sure we don't have any abnormal movement in that bearing. These are nice and tight. We want to make sure our bolts on the inside are in there, not missing any hardware. The critical piece to this whole equation is this piece right here, where the assembly actually attaches to the row unit shank. These are your bushings in here, so as you're traveling along at 10 miles an hour with this planer, this closing wheel assembly is constantly sitting there doing this. So something's got to be there to take that wear, and that's what these bushings are in here for. But if we allow these bushings to wear out too much, our closing wheel isn't going to track directly behind our opening, or our true V open. So if we don't get that true tracking behind it, we're only going to close one side of the trench. We may, leave some of that trench open. So we want to make sure that those are running true behind our opener. So if we get too much slop in those, that'll allow that closing wheel assembly to kick over to one side or the other, and then we're not running true with the openers. So we just kind of take some of the pressure off of those and just kind of wiggle those back and forth. Very little to no slop in these, so very good condition on these. If we did have a lot of slop, we would want to go ahead and replace those bushings. If you let the bushings go too long, then it's going to start eating into the arm itself, and replacing bushings isn't going to help you. You're going to have to replace the arm and everything. So staying on top of this is a pretty good idea. So just wiggling that back and forth, not a lot of play, we're good to go there. Another option that you do have for closing wheels bushings, if you're looking at replacing closing wheel bushings, another product that we offer through Sloan Express is the actual closing wheel bearing kit. So you get a kit, and that will do one row. Comes with the 2 collars and the 2 bearings. Basically, you're going to remove the old bushing, and you're going to use these in place and slide this bearing in there. Then you don't have to worry about that wear and tear anymore on that bushing. It's got a constant ride on that bearing to be able to flex up and down as it needs to. So
what brand are those?
These are from Copperhead Ag, but you can get them through the Sloan Express catalog or on their website. Great product there. Another product that we do have from Sloan Express is the actual gauge wheel repair kit. So we have a stud kit that will fill in here if you have any abnormal wear inside here. You break a stud off. This is an actual repair kit, also from Copperhead Ag. And then we do have the new updated style arms. And I want to open this up so you can get a good look at this bushing that's in here. This kit comes with one arm, all the hardware needed, gauge wheel arm, and the bushing installed as well. So if you pull this bushing out, it's only threaded on the inside, so all the load is going to be to the flat side of that bushing, so you're not wearing on your threads, and that's where you're going to get the play coming out of that gauge wheel arm like we talked about. Same style that is in the Deere gauge wheel arm, that's the exact same bushing that they use. So another good option for you if you do need to replace those arms. But it comes with all the hardware, everything you need to do that gauge wheel. All right, I wanted to talk about one more product from Sloan Express while we're talking about closing wheels and the row unit. We do offer the Copperhead and the Yetter closing wheels, so the Yetter twisters and then the Copperhead field cruisers. Great option if you're having trouble with wetter conditions, getting that trench to seal. These kits come with all the shims and everything that you need to do one row. So you would just remove the existing hardware, save that hardware, and then you can either buy them in complete units, which comes with both halves, the ring with the spikes or the twisters, and a new bearing. You would save your bolt, and these will come with extra shims, and you're going to attach those, and you're going to set the clearance down here where those two come together. You're going to set that clearance to 1.5 inches, and that's what those shim packs are for. So you can get them in complete kits like these, or you can these are the Copperheads. The Copperheads also come in complete units like this, or you can get just the rings, so you can take your existing closing wheel, you can undo all the bolts around it and separate the two halves, and then you can add the ring and put the two halves together. So both of those options are also available from Sloan Express if you're wanting to go to the spike closing wheels. All right, so now we've been over the row unit, we want to go over the actual meter and the brush belt itself. So we're going to start with the meter itself. This is the ExactEmerge meter. So to open him up, we're just going to take our rubber flap, kick him open, and the door opens. So a couple things we want to check for in here. Main thing, we want to make sure that this keeper is in there. This is going to affect our hub height. We want to make sure that that's in there, not broke, anything like that. We want to check the way that that hub spins and make sure that bearing doesn't have any play in it, no binding, anything like that. Just nice and smooth like this one here. Next thing you want to look at is your double eliminator. So this is what actually knocks a second seed off if the vac system picks up 2 seeds in the disc. So we're looking at these little fingers here, and we want to make sure that they're not bent, chewed up, any pieces missing off of them, anything like that. So looking at our slide here, we just want to make sure that this guy sits down in there. There we go. Want to make sure he sits down in there and slides freely. So he's got the detents, and you can see these lines. Depending on what side of seed you're using, 9 times out of 10 in corn, you're going to be right there in that middle position. If you're planting beans, you would be all the way down in the lower position. But just want to make sure that he can slide freely, and that when he's in his detent position, he doesn't move around, anything like that. Next thing we're looking at is the secondary eliminator. We want to make sure that these fingers are all intact, nothing's broke, anything chewed off, anything like that. All that looks really good. This is our transition from where the meter spins around. This is our transition where it's going to be handed off to the brush belt itself. Want to make sure we don't have any grooves cut, anything like that. Nice and smooth transition there. So these all look good. This is a replaceable part if we get a lot of wear on that end. But nice and smooth on this one. He looks good. Nothing to worry about there. Next thing is looking at the actual housing itself. So we are going to see a little bit of groove from where that bowl has been riding. So this groove right here, that's where that bowl has actually been riding on that unit. And that's perfectly fine. We just don't want to get a really, really deep groove cut in here. And that's what these ceramic pads are in here to take care of. So that bowl is going to be sitting on top of those ceramic pads. So as you can see, if I run my fingernail across that, I catch at that ceramic pad. So those sit up just a little bit higher than the housing itself. And you can see on these pads, you've got this little wear indicator, this little indent right here. Once you cannot see that little indent anymore, it's time to replace the pads. You can flip pads from top to bottom. They're interchangeable. You'll see that usually these two have a little bit more wear on them than these two, just for the way that bowl sits in there. It's going to have a little bit more drag down on this side than it does up on this outer end. So you can actually flop those front, or top to bottom. They are interchangeable. Get a little bit more wear life out of them. But we can see all the wear indicators on here, so these all look good. No need for concern there. We'll move on to our door. So this is our vac door. Pretty critical part of the whole operation is this seal right here. So you can pop him out. We want to look at him, make sure he doesn't have any tears, any cracks, any things like that. You'll have some dry rot issues with these. Just want to make sure we don't have any holes, any cracks, anything like that. That guy looks good. But if you do lose this guy, or we get a crack in him, we're going to lose vacuum inside the meter and start suffering population and spacing, stuff like that. We'll move on to the knockout wheel. So as that bowl comes around, it's going to have a pool of seed here. As that bowl comes around, that knockout wheel is going to be riding somewhere right around in this area. So as he comes around, vacuum stops at about the same time that wheel comes through, and that wheel actually plants that seed down in to the top of this brush. So no handoff, it's all a transition-free handoff. As it's picked up from the meter is how it's going to be delivered to the brush belt. And that's this guy's job. So we want to make sure that he's free to spin. Want to make sure his spring is in good shape. If we do need to get that guy out, we have a little tab right here. We can pull that tab back, and he'll slide right up and out of there. And then we can get a really good look at him. Make sure he doesn't have any teeth broke off. Make sure his spring's working good. This one's in good shape, so we'll put him back in. Start that in, and then snap him right back into place. So your bowls themselves, we want to take a look at these. So we'll talk about storage of these. Really good idea at the end of the season to take these out of the planter, get a metal rod, dowel rod, something, and we want to store those bowls in this position. That's going to make sure that they don't get any type of warping. We don't want to have the bowl sit there and have a bunch of junk stacked up on them, because that's going to make that bowl not its true shape. So hang them up, and then when we get them down, you can take a good look at them. What you're looking for here is any type of grooving cut around here, any type of really deep groove cut. That'd be where it's writing on the vac seal. So I want to make sure that we don't have a real deep groove cut. That looks good there. Want to make sure all our holes are clean and free of foreign material. And then looking at the back side here, this is the side that would be writing on our housing and our pads. Want to make sure we're not getting any really deep grooves cut in him. These all look really good. And then our strips down here, just make sure that nothing's broke off, anything to that effect. So these strips and then this agitator strip down here is what kind of keeps that seed pool stirred up so that we can keep everything free. So we've got two separate agitator strips. The one that's currently installed would be for the soybeans. It's smooth. And then we have the green one. That is the one you're going to put in for corn. It's more of a rough surface. Just take a look at those and make sure we don't have any wear, any chipping going on the leading edges of those, and make sure that stuff isn't peeling away. So to get this guy out, if we flip the meter over, we've got these tabs right here, and that would be these tabs on here. So you can just press these guys in. Soybean agitator strip is removed, and then we can take our corn agitator strip, get some of the graphite out of there. Snap him into place. Snap him into place just like that. If you do have your corn strips in, the leading edge will be here and here. This is where they'll start to wear first. You'll wear those little rough spots down. Want to make sure those are in good shape. So that's kind of the meter. So we'll move on to the brush belt. So this is our brush belt cartridge removed from the planter. A couple things on the outside. We have our gearbox that drives the brush belt itself. Want to take a look at those teeth on that guy. Make sure we don't have any gone, any chewed up, any abnormal wear there. Everything looks really good there. This is our tensioning device. So once again, during storage, we want to make sure that all that tension is taken off. Before we start planning again, we're going to tension that belt just like that, arrow pointing down. So we'll go ahead and detension him. We'll take this guy apart. So we've got these tabs on the side. Those up, out of the way, and he'll pull up and out of there, exposing our brush. So we can see our brush, we can see our springs. That's what we're actually turning when we do the tensioning and detensioning of the belt. We just want to make sure that those springs are in good shape, nothing broke there, making sure our cam here is in good shape, nothing broke, nothing missing out of him, everything looks good there. We can remove our brush belt sensor, pop him out. So just looking here, make sure our lens is clean, making sure none of our lenses are cracked, anything like that. Take a look at our terminals in here, make sure we don't have any corrosion, anything like that, broken terminals. This looks really good.
So that's counting the seeds.
That's counting the seeds, yep, that's where all the magic happens right there. So I'm gonna go ahead and take the lower cover off. So we've still got the tabs down here. So we're gonna remove those. The lower cover comes out. This guy just sits down in that hole, so we'll pull him out, set him to the side. Then we can push up on our idler, and we can actually remove that belt. So what we're looking for here on the belt is on the back side, we want to make sure none of this is peeling apart, anything like that. Looks really good here, no frays. So the belt itself, we just want to make sure that we don't have a deep groove cut in it. As they wear, that's what you'll see is kind of more of a trench-like look. And that'll be an indicator that we need to go ahead and replace that brush belt. Still nice and flat on this one. Looks to be in very good shape. We want to make sure that we don't have any chunks missing out of it. Maybe Mickey Mouse and the gang got into it over the winter and chewed a hole in it. We want to make sure nothing there.
Oh, surely not.
Yeah, I know. So, looks good here. Everything looks good on that belt. We'll set him off to the side. So while we got him out, we're going to pull out our guides. So there's one guide there, and there's the top guide there. So what we're looking for here, this is where the belt is going to ride. So that seat is going to be planted in here, and it's going to actually run against this guide. So over time, you'll start to wear a groove right around in here, and that would allow seed to roll, seed to bounce, things like that. That's going to affect our spacing, singulation, stuff like that. So we want to make sure we're just nice and flat there. We don't have any groove cut, and that one looks really good shape. Same thing with the top guide. We just want to make sure no grooves cut, anything like that. That one looks to be in very, very good shape. Leave him alone. Your main guide down the side here, just the same thing. Want to look for any grooves being cut, any type of abnormal wear there. This one's nice and flat. That's going to give our seat a nice smooth surface to run on. We don't have to worry about any bounce, anything like that. So while we've got the belt out, good idea to go ahead and check your idler roller. Just make sure he can roll free, no grinding, binding, anything like that. Not abnormally loose for the bearing. Same thing with the top gearbox. Make sure he spins freely. Make sure we don't have any bearing issues with this top bearing. Everything's nice and tight on this one, so I don't think we got anything going on here. Last thing I would want to inspect is my belt conditioner. So as this belt rolls around, the seat is dropped, and then it goes through this belt conditioner. So that just kind of, you know, shakes these bristles out, gets the dirt, graphite, stuff like that out. So as it comes around to pick up another seat, it's nice and clear. I want to make sure we don't have that wore down so bad that it becomes an X-Acto knife. Those will become very, very sharp, and then you'll trim off the leading edge of your brush there. So if we did have to replace that guy, we can just snap him out. And then he pulls out, gets a pair of pliers, but he pulls out right there. Then you can pull that guy out and replace him as well. Very good shape on this one. Don't see hardly any wear at all, so we're gonna let him go another year. So this is probably, the meter and the brush belt themselves are probably the most critical things that we can look at for seed placement. We don't want any roll, we don't want any bounce in that seed. We want a seamless transition. That's how we're going to achieve that, you know, perfect spacing. So more time we spend in here and that meter, the better that planter is going to perform. All right, so we're going to go ahead and reassemble this unit here. So we're going to start with our brush belt. So we've got a tab here that we need to set down in. There's a pin down here. I don't know if you can get in there and see that. There's a roll pin down through there where this guy's actually going to hook.
Yeah, there it is.
Yep. So we want to make sure we get him hooked down in there. Slide him down. Get our seed sensor harness. Slide him down. We'll go ahead and plug our seed sensor in. That one feels good, so I want to make sure that we can't pull that guy away. That would mean that we're not hooked in the bottom. So that one there, we can't pull him away, so he's in there good. Take our hood, line our latch up with our tab back here. He's down nice and flat. Then we're going to take our meter, put him back on. We want to make sure that that meter should basically just kind of fall right into place. If you have to force it shut with this, that probably means your brush belt isn't hooked and it's not sitting in there far enough. So shouldn't take much force at all to get that hook to hook. That one there just falls right into place. So hook him. All right, so while we're at this point, we want to go ahead and talk about another adjustment we can make on the planter. So we're gonna open this door up and we're gonna talk about hub height. So this is a pretty critical adjustment on these high-speed planters. Not getting this adjustment right will affect spacing big time. So we've got our bowl in, we've got him latched, and we're gonna go ahead and turn this guy. So as you can see, very minimal to no effort to make that guy turn. So we want a little bit of drag here. If I pull him away from the motor, you can almost see that he freezes. That's gonna be entirely too loose. As you can see up here, I've got a giant gap in between my bowl and my housing. We don't want that gap there. So we'll show you how to adjust that. So we're gonna unlatch the bowl. And we're gonna get him out of the way. We're gonna go ahead and pull this keeper out. And if you look down in there, you can see those holes and these slots right here. So we can actually turn to tighten or loosen this hub height assembly to make our drag better on that bowl. So I'm gonna pull him away for now. I'm gonna hold the back side of the shaft and I'm gonna turn this guy, give him a few turns. That's gonna bring the hub closer, which is gonna bring the bowl closer to the housing.
You just line it up with
Gonna line it up with those holes, so multiple different positions, so we can do full turns, or we've got these holes here to where we can just do half turns. So we can really get some fine tune out of this guy. So there would be a half a turn there, there's a quarter a turn, and there would be a full turn. So a lot of fine tuning you can do with this. Latch him back. Still pretty loose, so I need to do that again. Do a couple more turns out of him. We'll go ahead and I'm gonna give him a full and then a half.
1.5.
Yep. So I've got my other hole lined up.
So this could be a tedious task. You got to do this
Extremely,
24 times.
Yeah, extremely, but
It's got to be right.
it is extremely critical that we get this adjustment right. So we're getting better. You can see our gap is decreasing. We're starting to get a little drag, but we still got a little bit of freewheel there. We don't want that freewheel. So we'll do it one more time here.
So if that bowl was warped, you'd have tight spots and loose spots.
Correct. I'm gonna give him another turn here, but we're gonna get close here. That's sloppy.
Yeah.
You can see our gap is none. We are riding on the pad now. And you can see taking a little bit of effort to go ahead and turn that bowl. So high-speed planters, we want to keep them pretty tight on this adjustment. We don't want them so tight that we can't turn them at all, but we do need to keep them pretty tight. That's going to help the meter plant the way it's designed to. So
It needs to ride on those pads.
it needs to ride on those pads and have a little bit of drag there, and that's gonna keep everything held in place where it needs to be, keep vibration down, things like that. So this one here, that's about how I would start all of them, and then we would actually run the unit and make fine-tune adjustments from there. All right, so now we're at the back of the planter. A couple other things we wanted to point out, guys. Always want to be looking at these vac hoses. Once again, anything that's going to cause a vac leak is going to affect our performance of the planter. So I like to take these hoses off of every row, and I like to just do a quick visual inspection, make sure we don't have any holes in them, any spot where it's been rubbing, and then checking where they actually hook up, make sure we don't have any cracks, anything busted there. So that one is pretty good shape there. Put him back on. Same thing with our CCS delivery hoses. We'll pop those out.
So that's where the seed's coming from.
So we use this fan. This is the CCS fan. We use this fan to pressurize these tanks. As pressure builds in the tank, it's going to blow seed. So we got air coming in, and then our delivery tubes on the other side. It's going to blow that seed through the tube. Now, as you can see down in here, we have this little elbow in our mini hopper. So that little elbow sits down in that mini hopper. So as that seed pool pulls up and blocks this passage off, now our pressure equalizes in our meter and our tank, so we don't get any more seed flow. As the seed pool drops, we have a pressure drop because we've opened this hole up again. Seed is allowed to flow. So that's kind of how the CCS system works. Pretty critical for talc and graphite use in these, the 80-20 mix. Talc is going to keep everything lubed up inside the hoses flowing good. The graphite is going to help lubricate the meter and the brush belt. So checking those vac lines, CCS lines, we want to make sure we don't have any holes. Pop our hose off. There is an O-ring seal in there. Just want to make sure that O-ring's in there, not busted, not cracked, anything like that. So he looks good. Latch him, put our door back on. While we're talking about CCS, this is our main manifold hose. So we're connected to the fan back here. This is a very good item for wear. And if you can see on this one, we are actually starting to get a little bit of breakthrough from the wire winding in here. You can see where that's starting to peel apart. So eventually that's going to lead to a hole inside this tube, and which is allow that air to come out here instead of go into the tank. So you could start having some kind of delivery issues there.
So you need to make sure there's not a whole bunch of stuff rubbing on it.
Yep. It's kind of a busy area back in here. These are all our control units, MTG, wireless, our wireless data servers in there. We've got a lot of stuff going on right here, so this is a pretty common failure area on these, is they will get a hole in them, and then you won't be able to build enough tank pressure. So I would recommend, we're probably getting close to needing to replace that. I don't see any holes yet, but we are starting to kind of wear through on that manifold just a bit. So good area to keep an eye on. Now we'll go up and we will talk about the air compressor. So we've got the hydraulic driven air compressor up there. His only job on this planter is to control the pneumatic controlled row cleaners and the pneumatic controlled closing system. So we'll go through some maintenance on here. The first thing we want to be doing is making sure that we're draining that tank. Because as we compress the air, the water is going to be condensed down into the tank. It's going to allow our valves up here to be contaminated with water. So we need to be draining that. You know, the sticker says daily. I would recommend at least once a week, if nothing else. I want to make sure that tank's getting drained, so we try to keep as much of that water out of that system as possible. The other thing you've got on the compressor itself, we've got a couple maintenance items on him. First one's going to be our intake air filter. So we can take him off.
I'm sure those don't get dirty at all.
No. Take him off, and you can see the filter there. Just want to make sure that we can blow him out with compressed air, something like that. Probably not a bad idea to replace him every couple years. Just making sure that we're pulling good clean air into that compressor. This one actually looks pretty clean, which is pretty abnormal. This is a highly missed maintenance item on these. Put him back on.
Usually by the time you look at that, it's probably pretty trashed, isn't it?
There's, 5-gallon bucket worth of dust comes out of those guys usually. Next thing we've got, if you want to come around maybe to that side, we do have a bubble sight gauge indicator for our air compressor oil. I want to be right in the middle of that bubble. That one looks really good. Once again, every year be draining this oil. You've got a drain valve here that pulls out to a drain hose.
Oh, that's convenient.
Drain that, and then your fill cap is right here. You take him off and fill him with air compressor oil. So a couple things to keep in mind on that air compressor. Don't forget about him. Probably a pretty highly missed component on most of these planters. While we're up here, we'll just kind of look at you know, any type of hydraulic leaks on the compressor system. I don't see anything obviously leaking. So this would be our hydraulic motor.
Yeah, there's a hydraulic motor right there.
Yep, hydraulic motor, and then our accumulator for any spike in pressure, anything like that. Everything looks good there. Don't see any obvious signs of leaking. So air compressor checks out pretty good there. All right, so now we're at the kind of the front of the CCS system here. Just a couple more places we want to point out to check. So as this planer folds and unfolds, this is the area that's going to take some of that abuse. So where all these hoses come together, you need to kind of separate all these guys out one at a time. And what we're looking for is any sign of rubbing, any sign of holes, anything like that. Because once again, if we get a hole in one of these, we're going to leak air out of our CCS system and not be able to deliver seed down the rows. So just kind of do a quick visual inspection of all these hoses right at the fold points. I'm not seeing anything obvious on these guys. So another part to look at is on the bottom of the tank itself. So this is our actual CCS manifold. That's this entire bottom piece right here. I want to make sure that our clamps are all tight and not broke, anything there. You'll see some splitting starting to take place where these clamps have been on these hoses for a while. So just do a quick visual inspection on all these. All these clamps look really good. I don't see any signs of splits, anything like that. When you actually pressurize the tanks, you don't want to see any massive air leaks. So what I recommend doing there is sprinkling just some talc in the bottom of the tanks and then lighten that CCS fan up. And if you have any type of massive leak down in this area, you're going to be able to see it really quick because that talc's going to get blown right out there. So you can replace the seals in this manifold. It's not the easiest job in the world to do, but you can replace those seals. So, all right, now we want to talk a little bit about the hydraulic downforce system. So we kind of went over the sensor, some things to look at for there. The main components of the hydraulic downforce are the actuator itself. We have a solenoid valve that controls oil into that actuator. And then we have the pressure sensor that's telling the system feedback on what kind of pressure it's actually running on this system. So air is a pretty critical downfall to this system. So we want to make sure we get all the air bled out. And in order to do that, at the start and the end of each section on this planer, so on a 24 row, there'd be 4 of these guys sitting out here. And all these ExactEmerge planters with IRHD should come with a loop flushing hose. That should have been given to you when you got the planter. You're just gonna pull these caps
Or
off.
when you get the high-speed conversion.
Or when you get the high-speed conversion, yep. Pull these caps off. Make sure we're good and clean. And we're just gonna hook this hose up. So just from one end to the other. Now we're actually going to engage the hydraulic downforce, and what that does is allows oil to bypass the actuator and just do a continuous loop. So we're basically bleeding the system. Any air that's trapped in there, any air that got in there over the winter, we're going to go ahead and force all that air out. So we'll jump up in the cab and we'll show you what we're going to do there. All right, so we got our loop line hooked up. So now we're going to go through actually how to kind of engage that. So one way, there's a couple different ways to do it. The way I do it is just I come to my gauge wheel setting on my planter details. I'll go ahead and select him. I want to look at my downforce margin. So I'm going to select him. 190 pounds would be fine. You could go down to 150, it doesn't really matter. We just want to be able to make sure that it's going to flow hydraulics. So the next thing I want to make sure is my active downforce is turned on, so we're good to go there. So we've actually moved our hydraulic control to SCV number 5. It makes this process just a little bit easier. So I'm going to turn my flow up on SCV 5 to about 5. X out of him. And now we're going to actually put the planter down and make it think that it needs to start applying downforce. So we're just going to put the planter down. So now you see we get a warning pop up that says low hydraulic supply on 1 through 24. So at this point, we're going to actually engage our SCV number 5. And now we're actually flowing hydraulics through the system.
Feel it shake the whole machine.
Yeah. So another thing you can do is come into your tools tab. You can go to planter diagnostics and calibrations. And if you look at your hydraulic pressure, or not hydraulic pressure, but under procedures tab, and then we do like, if we just do an air purge test or an accumulator test, hit begin. It's going to give us
accumulator test.
I'm not doing one right now. I'm just looking at my hydraulic pressure.
Okay.
So that's giving me a readout that hydraulic pressure. So we do actually have hydraulics flowing. So we would want to do this for each section of the planter for about 3 minutes, and that's going to purge all the air out of those lungs. So if we shut number 5 off, we're going to see our pressure drop. And then then we'll get the low downforce on 1 through 24. If we engage again, we'll see our pressure come up. Low downforce on row unit 1 because that's where we have our loop line hose. So it's not actually getting any, but we are flowing hydraulic oil all the way throughout the system. So you want to do that for each section for about 3 minutes, and that's going to bleed all the air out of that system. So we'll go ahead and shut this one down, and then we'll go move the hose. All right, so now that we've got the first section bled out, we're going to remove our hose, caps back on. And we would move down to the end of this section. So this entire wing is one section, the back part of the planter is a section, and then the other wing would be one section.
Gotcha.
Move back to the end of this section. We got the hose plugged back in. And we would start the process all over again until we got through every section on the planter.
Yeah, and you like to move it to the SCV so you don't have to shut the tractor off every time you have to move.
So yeah, if we were in Power Beyond, we'd have to shut the tractor down, move our hose, start the tractor back up. With an SCV, we can shut the flow off
and
move
move
the hose. And then once we get all that done, I would move it back to a Power Beyond and let it do its thing. All right, so we finished bleeding out the planter. We went to each one of our sections, put our loop line in, flushed the system, got all the air out. Now we're actually going to do the air purge test to verify that we did get all the air out. So we're going to start by going to our tools tab, planter diagnostics and calibrations, procedures, and then we're going to do the air purge test. We're going to begin that procedure. We've got all 3 check marks, so everything's good, everything's happy, so we're going to hit next. We're going to tell it to start on row 1 and end on row 24, and we're just going to hit next. So what it's doing now is testing each one to see if there's any air stuck in the system. So what you're going to see is lines are going to start coming up on this graph to verify that everything's good, and as long as those go green, we're in good shape. So we'll sit here and we'll watch it and we'll see what happens here.
It's almost done.
Close. All right. So we got 24 green boxes. That means the system's happy with the air purge. So we got all the air bled out. So the next thing that we would want to do is do an accumulator test. So we're in our procedures tabs again. We're going to go to the accumulator test. We're going to begin that. Now we need to get some more hydraulic PSI. So if we go, we're in Power Beyond again, so we're only getting 467. We need more than that. So we're going to take our number 2 SCV. We're going to put him to about 3. And we're just going to deadhead that function. And that should allow the pump to go into stroke and allow the hydraulic pressure to build. So I deadhead number 2, that puts my pump into stroke, I get my pressure built. So I'm going to hit next. Same thing here. We're going to do row 1 through 24, and what this is going to do is run through and test each one of those actuators. So if we have a problem with the actuator itself or with a sensor, we're going to find that out during this test. So we're just going to hit next, and it's going to start doing its thing. You can feel it.
You can feel a rumble, yeah.
So same thing we're looking for here is we're just watching these bar graphs and making sure they all come up. Uh-oh.
That one's red.
That one's red. Alright, so now we're going to make all the meters spin. So we're going to double check that all our motors are good, that all our wiring harness to those motors are good. So once again, we're going to start by going to our tools page. And we're going to go to our planner and planner runoff procedure. And we're going to go to the planner runoff tab. So the first thing is we can tell it how much population we want and our test speed, and then we can hit start. But because this has an electronic power generator on the PTO, the first thing we need to do is get our PTO up and running. So we're going to come down over to our other page here. We have our EPG status. So right now he's off. So the first thing we're going to do is engage the PTO. We're going to give her a little RPM, and we're going to turn our EPG on. So now we should be getting our 56 volts back to the motors, and you notice our little gear went to ready, so we're ready to start. So we'll go to our diagnostics and calibrations tab, go to our procedures, we'll go to runoff procedures, we're on our planner. I'm going to go with 36,000 seeds per acre, and I'm going to do it at 10 miles an hour, and then I'm going to hit start. It's going to tell me everything's going to start turning. Don't stick your fingers in it. Let's start again. And now all of our rows should be turning. So we're going to get out and do a visual inspection and make sure that everything is in fact turning.
She's spinning. So we were doing the accumulator charge test where we're cycling each actuator and checking the pressures on them, and we're having multiple row units fail, but one always fails, or one always passes and 2 always fails. So we went ahead and swapped the pressure sensors in these actuators, and we're going to retry the test. And then if number 2 fails, then we know we most likely got a sensor issue, and that's most likely the cause on all the other row units.
All right, so we swapped the sensors around, we did the test again. Row number 1 was always passing, row number 2 was always failing. So we took the sensor off 2, put it on 1, sensor off 1, put it on 2. So if the sensor would have been the problem, row number 1 should have failed, row number 2 should have passed. That's not what happened. Row number 1 continued to pass, row number 2 continued to fail. So we know it's not in the sensors. So I went in and did a valve flush test, which forces high pressure oil through this. So any type of contaminants or any valve that's maybe stuck or hanging up in there, it's going to force that guy to move so he can open all the way several times. Get some lubrication in there, get those valves maybe to quit sticking. Did that several times, and then did the actuator control valve test. Once again, moving the valve, exercising the valve part. Everything worked great, passed that test, came back to the accumulator test, did that once more, everything passed again. So.
And the accumulator test is what we were failing.
Right.
And it's just because we needed to flush it and work the valves and get everything cycling enough to where it finally started working again.
Correct. So I think we're good on downforce.
Perfect. Okay, so we got everything working on the planter now, finally. And we've inspected, mostly everything for the video. And then tomorrow, we'll go through all the other row units. And Caleb's gonna do that while I inspect the tractor. We would like to be able to run this planter, but let's face it, it's just way too cold outside. We can't run the planter in this shop because we'll just fog this whole shop with graphite and make a giant mess, and we don't want to do that. And it's too cold to take the planter outside and run it. So Caleb, why don't you tell us what we were gonna do there?
Yeah, so like Zeth said, it's a bombing, 4 degrees outside.
We're up to 4 now.
We're up to 4, so we're gaining on it. Typically what we would want to do is we would actually want to put corn in each one of these meters, and we would run each meter individually so we could make any fine-tune adjustments that we would want to do there. We've got a harness that we would plug into the back of the planter. We could carry a display around with us and walk up to each row and make it actually spit out corn. The only thing we can't simulate is ground conditions, but we can simulate speed and we can change population, so we could test each meter individually to make sure it was planted correctly.
We're checking the simulation.
Spacing, just making sure that it can plant the correct population and do a good job spacing it out. Unfortunately, circumstances aren't going to allow us to do that because, like Zeth said, we do not want to fog this guy's shed out, and we would definitely make a mess in here running these vac motors. Some other things that we would typically do outside, that we're not going to be able to do here, we would want to, work the markers, check all the functionality of the markers out, make sure we don't have any cracks, anything broke on the marker arms, make sure that they do function in manual and automatic mode both. Not that guys really use markers much anymore, but still something to take a look at while you're doing a planter inspection. Some other things, we would probably want to jack these planters up a little bit and check these wheel frames out. And we may get to that tomorrow, I don't know. This planter happens to have tracks on the back, so not really anything that we can really do with those at this point in time, but check the wing wheels out. And then, just a basic, greasing the machine, showing all those grease points and making sure the machine's lubricated and ready to go. But we'll finish tearing the row units down tomorrow, and if we find something cool, we will let you know.
All right, we're going to continue this tomorrow, and we'll get the rest of the planter finished up, and then I'm going to start this tractor inspection.